Hello, we are moving on from our modeling unit into direct and inverse variation. So we've talked a lot about cubic modeling, which is very similar. It feels very familiar with quadratic modeling because of the fact that they're both polynomials, so they behave in sort of polynomial types of ways. Now, this is kind of a new type of modeling that we haven't really talked about unless you've talked about it in previous classes, which I'm not really sure if you have. But it's called direct and inverse variation. It's very reliant, this type of modeling is very reliant on these phrases to be directly proportional or inversely proportional. So these would be your major clues if it says this, that it is a variation type of problem, that they are proportional in some way. So we have two different ways that things can be proportional, directly or inversely. And it has the phrase y varies directly, or y is directly proportional to x. And that will tell you, okay, we're talking about a proportional relationship. Now, the format here for directly proportional is y equals kx. And all this means k is just a number. That's it. It is a linear relationship. So k is just a number. Here you can see this would be what k is 6. This is when k is 2. This is when k is a half. And notice if we were thinking about this as mx plus b, because it's just a line, if we put plus 0 here, which doesn't change anything, our y-intercept is 0, and our slope is k. So we can go in here, we can see up 2 over 1, up 2 over 1. And that's when you have a k of 2. Versus a half, you would be up 1 over 2, up 1 over 2. So your k is really just your slope. But because we're talking about direct variation, we use a different variable to just kind of change or shift our thought on it. So a few key points here. It's always just a line. It always goes through the origin. And that's it. So that's all I want you to know for this guy. We will practice what this means further down. So if it's still, you're just like, wait, what is direct proportionality? We'll get to practicing it in context in a second. The other type that we have is inversely proportional. And so here we have the phrase y varies inversely with x. And it looks something like this, which is a rational function. So instead of it being a line, it's a rational function. Because if we look at it, remember that rational just means fraction. Y equals k times 1 over x. And remember that k is just a number, some sort of constant, right? Or we can write it as y equals k over x. So this format right here, these guys are the same thing. I think we can understand that those are the same thing. This format right here is great for solving for k. For all of these problems, we're going to solve for k first in order to find the equation, find the model. This format is great for when k is a fraction. I think a lot of times we have a hard time when fractions are going on, and it would be a fraction within a fraction. And so a lot of times we'll use this guy when we have our k, or our proportionality, our number of proportionality is a fraction. So these are the general ideas, is that when we have this phrase, it varies directly or is directly proportional, or it varies inversely. This is all it means, is that it's one of these two relationships. And so let's get started on practicing it. The cost of a phone varies directly with the length of the call, m in minutes. A recent 5-minute phone call costs 60 cents. Varies directly. If you're somebody who likes to highlight numbers or highlight phrases to be like, oh, this is what I'm supposed to do, varies directly is your huge piece here. And then I want you to always link back to this idea. Y varies directly with x. And this would be the equation that comes from that phrase. So if I said the cost varies directly with the length, Y varies directly with X. So then that tells you if I'm varying directly, first of all, I'm going to write out my direct variation formula. Direct variation formula. Then Y is actually my cost, C. So I'm going to replace it with C. And the length, it says, actually that's supposed to be M. So K times M. I'm going to call this C of M, right? This notation is like F of X, but it's C of M, where K is just a number. And now we need to find out what is K. So if I go ahead and finish reading this problem, it says a recent 5-minute, which is time, minutes, will cost that much. So I've just been given, hey, when C equals 60 cents, M equals 5. When I'm given a pair of numbers that go together, it's just an ordered pair. It's a point. It goes into the formula. In order to solve for K, I have to plug in a point or an ordered pair. So if I plug in 5 for minutes, K times 5 equals, and 60 cents for cost, right? That whole thing means cost. I can go ahead and solve for K. Let's do that on your own. If you divide both sides by 5, you get that K is equal to 0.12, which is great. It feels like we've just accomplished something, which we have, which is we solved for K. But what we need to do is we need to write the direct variation model for this situation. In other words, write the equation. So the final step is that I need to take this K value and I need to plug it in for this formula. But instead of Y, I'm going to use C of M equals, and instead of K, I'm going to put 0.12, and then I put M. So that's the process. To review the process for writing a direct variation model, you start with your blanket formula for direct variation. You establish in the wording what goes in for Y and what goes in for X. It's always Y varies directly with X. So you say, okay, well, if that is Y, I'm going to replace Y with this. If that is X, then I'm going to replace X with that. After you've replaced your variables, step 1, write out the formula. Step 2, replace the variables accordingly. Step 3, you need to solve for K. You do that by plugging in a point. Once you solve for K, you just have to plug K back in and then have your variables, right? Because it wouldn't be an equation if you didn't have a variable. So that is the process. So now we get to use our model. Again, in a test, if you didn't know how to do this and you're totally lost, make something up. Once you make something up, then you can just use that and get all of your follow-through points. Testing strategy. Use your model to predict the cost of a 7-minute phone call. 7 minutes goes in for our time, which is M. So I want to find C of 7 minutes, which means all I have to do is plug in 7 for that value. Go ahead and find that on your own. 7 times 0.12 is 0.84. So 0.84 US dollars, or in other words, 84 cents. This says find the length of a call. Length of the call is our minutes, which is unknown, but we do have a cost. So I plug in 1.56 for my cost, and it's equal to 0.12 times M. Go ahead and solve for M. We get 13 equals M. So your answer is 13 minutes. You just divided both sides by 0.12. Here it says that we want to write down the cost of per minute for phone calls. Write down the cost per minute of phone calls. When we have a rate of comparing something to something, something per something, cost per minute. That's the cost over the minutes. when we take one variable and divide it by the other variable, we're really just talking about slope. So this is something that continues to pop up in a lot of our problems. And I know that sometimes it's really confusing to see when it is slope. So here's your strategy. When it's something per minute, when we have a relationship or a ratio between one variable and the next, pay attention. Cost is pretty much my y, minutes is pretty much my x. And the fact that it's that over that means we're talking about the slope. And since this is a line, an equation of a line where my y-intercept plus 0 is 0 and my slope is 0.12, the answer is just 0.12 cents or dollars, so 12 cents per minute. Now, if that's something that didn't make sense for you, then we have a bunch of information here, a bunch of points that we can use. We just found a point here, which was 7 minutes, 84 cents, or 13 minutes, $1.56, or the original 5 minutes and 60 cents. And all you have to do is then use any of those points and figure out, well, if I was on it for 7 minutes, okay, I had 84 cents that I was charged. It will also equal if you took 13 minutes and divided it out of $1.56. It would also be equal to 5 minutes divided out of 60 cents. They would all provide you back to the same answer. So that's 12 cents or $0.12 per minute. But realize it's just our slope. Okay, so the hardest part probably about this problem is creating the model. We talked about a strategy of how to go through that. The rest of it is just applying your model appropriately. A tricky little slope problem at the end, very typical IB level problem.